Good morning, good afternoon, and good evening. Wherever you're dialing in from around the world, whatever time zone you're in, welcome. Thank you to buildingSMART, particularly the team in Europe, for putting on this fantastic event. My name is Chris Rozelle. I'm the Managing Director of dRofus and calling you from Perth in Western Australia today. So my presentation is about Building Lifecycle Intelligence. My company dRofus is focused on data. We're a software development company and part of the Nemetschek Group, who develop the best of breed tools for the AECO industry. In recent years, the world has become obsessed with data. Our industry has seen a shift towards data-driven design and construction processes and the collaborative production of lifecycle data. Now, you may have heard the term the golden thread of information, and dRofus provides a way to deliver this, to carry information through all of the project phases, but also beyond that into the operations phase, and to enable feedback loops and knowledge sharing back to new projects. This is what we call Building Lifecycle Intelligence. Our software started as a way to capture client requirements and combine this with design data throughout each of the project stages. We have a flexible interface so you can set up whatever data ontology, aka properties, that you need, and importantly be able to assign responsibility to different stakeholders who are required to provide that information. This is very relevant today, of course, as asset information requirements together with PIRs, EIRs, etc. are key to project delivery. Most projects start by first defining the site, building levels, and the key functions within the building, the key spaces required to perform those activities. And this data guides what the architect designs. Usually it needs to be compared against and tracked throughout the different stages, that golden thread as we mentioned earlier. The contents of the room in terms of AV equipment, furniture, lighting fixtures, carpet, walls and ceiling finishes, etc. We capture all of this, not only in terms of the planned quantity in each room, but also the specification of these items and the designed or modeled quantities as well. We have a bi-directional, somewhat symbiotic link with the models. Design requirements such as the proximity or relationship to other rooms, daylight requirements, occupancy numbers, temperature ranges, etc., which in turn affect system design, we provide a way to capture all of that information collaboratively. MEP systems can be planned in dRofus or imported from the model. What we often see is that these systems may not be fully modeled, or that there's perhaps data missing, such as the classification. Maybe the link between the systems also, hasn't been captured, how an electrical system connects to a HVAC system, for instance. So we're able to plug these information gaps and, where necessary, synchronize that data back to the models. So you're building up a complete picture of everything that's required to plan, design and construct the facility based on the collective data or knowledge of the various stakeholders. And all of this data, as I mentioned, is linked to the models, but without the need for the data to live inside the models or to have been authored there. This buildup of data also enables various downstream tasks, such as commissioning, validation, capturing of asset and product data, plus the associated FM documentation. And this in turn leads to a comprehensive information handover from the project team to the operations team. Or better still, linking that golden thread, your golden database, to the BMS and FM tools. These days, software systems need to connect with others through direct connections to other software platforms, but also via APIs. So you can do fun stuff like building intelligence dashboards. You can even embed dRofus into other applications, such as field BIM type systems. So our core message is to make data the foundation of your software ecosystem. Models and documents are, of course, important, but deriving everything from a model limits your options. Using data as the backbone to connect all of your openBIM systems, we feel is a much better approach, as do many of our customers who are now speaking publicly about this. I was fortunate to introduce Building Lifecycle Intelligence at a buildingSMART event roughly a year ago. And this video is available through buildingSMART's Vimeo channel if you're interested in looking that up. I mentioned in this that in 2017, a dRofus customer won a buildingSMART award. Also in 2018, again in 2019, and at the time, there were several contenders for the 2020 awards. And I'm pleased to say that Auckland Airport won this, who for us are a very new but also very interesting customer. You know, they share our vision around using data as the foundation of their asset management activities. So we realized we had to start sharing these stories. So we've actually created a sort of TEDx style series of webinars branded the Innovator Basecamp. So you can hear from the likes of Auckland Airport and several other of our visionary customers about their projects and their approach to building lifecycle intelligence. That gives me now a perfect segue to introduce Hiyama-san from Takenaka Corporation. Arigatou gozaimashita. Thank you very much, and I'll hand over to Hiyama-san now.
Hello everyone, I'm Tomonori Hiyama from Takenaka Corporation Japan. Thank you for joining this webinar. I'm very happy to share our project with you and show our project data flows. Today's agenda is here, and I'd like to introduce you Takenaka briefly first, and our data flow. Here is a company profile. Achieved $11 billion in 2020. 7% of our business is design build practice. 7,700 employees, roughly 2,400 architects, and 2,300 construction managers, all in-house. It's not the largest in industry, but is a good size company. Takenaka started in 1610 as a master builder, built shrine and temples. The picture illustrates the construction site in that era. The guy marked with the box is a Toryo, master builder. Master builders did everything, consulted with client, did sketch, calculations, and managed construction. This is the background of Takenaka. Unlike other general contractors, they are exclusively focused on building constructions, no civil engineering projects. Adding barriers through BIM implementations, we try to improve our service and call it Takenaka IPD. We try to push it further to achieve the data-driven design build in near future. This is what we are engaged in to make the Toryo system of the future a reality. So here I will share the design build process. The project is Henetsu Steel Fabrication Headquarters in Osaka. Sange is one of our vendors whom we have been closely working together. Red area shows the site for the project next to their steel fabrication yard. Their requirements are first, better communication within the headquarter office. Second, workplace which can motivate workers to change their mindset to be innovative. And the last, building should become a showcase for their technology. You might have seen such division rule seen in nature. It's called the Voronoi division. Our team used the rule to create a new relation between the rooms inside the rectangular box. This shows how it is divided. Model flow in this project. Rhino to create the form and Archicad to complete the schematic design. This building was completed in 2020. Since it is a showcase for Sange, anyone can visit to see how it looks. Please take a look at the video of this project. This was the data flow when we drove the Sange project. The program model on top is a vehicle carrying information of the dRofus throughout the process. Each discipline, each department team make models separately. Once the construction model is ready, it is distributed to vendors so that they can make their own models to fabricate. Facility management model is created by the end of the construction for maintenance as a FM model. Let me show you the design build model and the data flow. As the design phase progresses, the design development releases the finalized information in the construction DPF. And our construction department uses this information for the planning process. Throughout the construction process, information from the design phase and construction phase will be constantly shared on the construction DPF. Takenaka aims to become a data-driven company in the near future, which means data will be stored in the data lake in order to reuse the data each project. Also, by integrating the customer's FM informations, it will enable us to provide new value-added service to our customers. Here is an example of how dRofus is used in an actual project. This project is to reconstruct our branch office, a two-story steel structure. The construction completed in July and now in use. From the early stage of the design, we adopted an openBIM approach. The primary showcase we used were ArchiCAD and Tekla as authoring soft. For MEP, we used the Japanese BIM software Revlo, dRofus as a data management tool, and the StreamBIM as the core of the common data environment. The data is used from the early design phase throughout the construction phase and even into the FM phase. We are building an ecosystem using several software packages as a common data environment using openBIM. There are three major types of data to be used: graphical data, non-graphical data, and documents. dRofus plays an important role as a system which handles non-graphical data and is the platform for all project-related data. The information controlled by dRofus is synchronized with ArchiCAD and authoring tool, and the information is then used in Storyboard and StreamBIM. It's important that all the stakeholders are managed with a proper access control in a common data environment. As I mentioned earlier, this project is already in operation, and we continuously work on maintaining and operating the data under appropriate access control. We would like to develop the data environment built around dRofus from the early design phase as a platform for long-lasting building lifecycle. Especially with customers, we communicate digitally using StreamBIM, which allows sharing of models and informations. We use dRofus as a building information database, which includes asset information and share the information as well. A trial is underway to set up a project information management department. That way, models and information can be used by all parties involved, regardless of whether they are in the design, construction, or FM phase. openBIM is the most important concept for us. Construction process involves more than 100 parties throughout the process. And we use Storyboard as a platform so that anyone can participate. Also, we use dRofus as information management tool so that everyone has access to project information. Thank you for taking the time to participate.